Okay, it's 8 o'clock. Grant, may I get started? Well, welcome everyone. A very good evening or a good late afternoon, depending upon where you are, to everyone. My name is Raghu Balakrishnan. I'm the Dean of Engineering at the Case School of Engineering. It's my pleasure to welcome you all here for this evening's event. First of all, thank you all for joining us for Tomorrow's Energy, a fireside chat with Mike Koralewski. Mike is the Chief Manufacturing Operations Officer at First Solar, the nation's largest domestic manufacturer of solar panels. First Solar is ramping up capacity to address demands of transitioning energy economies and has major manufacturing operations here in Northern Ohio. Now, this evening's event is timely as we've just wrapped up the COP26 summit in Glasgow and have again heard how urgently we must reduce greenhouse gas emissions and transition our economies to sustainable and renewable energy sources. Now, before I go any further, I'd like to thank our co-hosts for this evening's event. First, the CASE Alumni Association, which is tireless in its efforts in keeping our alumni connected and networked. Second, the Great Lakes Energy Institute. Since 2008, the Institute has supported energy-related research and scholarship at Case Western Reserve. Our speaker tonight is a member of GLEI's advisory board. Finally, our ThinkEnergy Fellows alumni group, who offered to open their fall networking event to all alumni. ThinkEnergy Fellows is an innovative, student-centric program focused on experiential learning. The program aims to enhance energy literacy among the next generation of executives, educators, politicians, and technology experts, giving students an opportunity to operate outside their comfort zones and exposing them to experiences beyond the classroom. The program is now in its 7th year and has produced industry leaders like tonight's moderator. Now I'd like to provide a bit more background on our featured speaker, Mike Koralewski. Mike is a 1994 graduate of the Case School of Engineering, having earned his bachelor's degree in chemical engineering at the Case School of Engineering, and then an MBA from Bowling Green State University. Last year, he was appointed Chief Manufacturing Operations Officer of First Solar. In this role, he oversees strategy for global manufacturing. He brings more than 20 years of experience to the executive leadership team. Prior to joining First Solar in 2006, Mike worked at Dana Incorporated, where he held several positions with global responsibility in operations and quality management. I understand that Mike serves on the executive boards of Toledo's Science Center, Imagination Station, and Lourdes University. He lives near Toledo with his wife, Jennifer, and their children, Caitlin, a senior at Duquesne University in Pittsburgh, and Colin, a freshman at Ohio Northern University. Mike, welcome and thank you for joining us tonight. Tonight's conversation will be moderated by alumna of the ThinkEnergy program, Marlena Praprost. Marley graduated from Case Western Reserve with a bachelor's and a master's in mechanical engineering and was a 2016-17 ThinkEnergy Fellow. She now works at the National Renewable Energy Laboratory, NREL, in Golden, Colorado. As a commercial buildings research engineer, she develops and analyzes a model of the nation's commercial building stock to assess the impact of a vast range of energy conservation measures and technologies. Marley, we're delighted that you could join us this evening. Our audience is looking forward to hearing from you both. Please join me in welcoming these two outstanding graduates of the Case School of Engineering. Over to you, Marley.
Thank you, and welcome everyone to what I believe is the first ThinkEnergy alumni event. So I first off want to thank the Dean for his opening remarks and for his continued support of the Great Lakes Energy Institute and our mission. And I was lucky enough to be selected as a fellow in 2016, and I would not be in the career I am now without that program. So it's been really amazing to see how much it's grown over the years and see how many student success stories have come from it. So I'd like to thank all the ThinkEnergy staff and the current fellows, as well as the alumni, for helping organize this event and for opening it up to a wider Case alumni audience so that you guys can see what we're all about and hear from one of the leaders in the solar industry. So if you were not able to check out First Solar before this event, they are really leading the charge in the solar industry and in the clean energy transition, not only in their advances in PV efficiency and generation potential, but also through their sustainable manufacturing practices. So when you think about the environmental impact of a product, it's not just the operation phase, it's really from material extraction all the way to when the product is no longer in use and how it's recycled. So First Solar's PV technology actually has the smallest carbon footprint of all solar technologies, as well as the lowest water footprint. So they've really made this life cycle analysis part of their mission when they're developing their technology. And they've also figured out a way to do it at a low cost. And they've made the fastest energy payback time of all PV technologies. So that's really crucial when we're trying to transition toward a clean energy future and trying to make the case for renewable energy. So Mike will obviously be able to tell us a lot more about First Solar, but I just wanted to recognize the amazing work that they do and acknowledge how grateful we are to have this time to talk with Mike. So with that, why don't we get into the discussion? I'm going to start with some questions that have been prepared by the ThinkEnergy Fellows, and then we'll save about 20 or 25 minutes toward the end for questions from the audience. So if you do have questions, you can put that in the Q&A box, and then we'll try to get to as many as we can toward the end. So why don't we get right into it? So Mike, as we know, you were a CASE alum, you were a chemical engineer. So why don't we just start out by telling us a little bit about your time at CASE and how you became interested in the solar industry and how that eventually led you to where you are today at First Solar.
Yeah, well, first of all, thank you very much for having me tonight, Marley, and the rest of the team. I greatly appreciate it. You know, so I look back at my time at CASE, and you know, when I graduated, I'd really had two real interests in where I wanted to apply my engineering degree, and that was in a hardcore manufacturing setting that really took something and transformed it into greatness, and then also in the energy sector. After CASE, I spent time at an automotive manufacturer, as mentioned earlier, where we spent a lot of time focused on next generation of devices for fuel efficiency. That really got me started to think about what's next. You know, a car was a small aspect of it, but you look back and say, hey, what's the big picture, the grid, you know, the homes and things like that. It just so happened at that time that First Solar was starting to really expand from a R&D centered organization to a manufacturing company. It was a startup at the time. I met with their leadership, loved their vision of leading the world's sustainable energy future, walked into their facility, and it was just a breath of fresh air just watching that transform, you know, these byproducts of mining operations, you know, into something, you know, transferable. So, you know, I think the interest in energy and the interest in manufacturing just lined up really, really nicely at First Solar. I was lucky enough to enter at a time in the solar industry where we're really starting to take off. The European Union was, really starting to gravitate into renewables at the time, and we were at the right place at the right time. I started in their quality and reliability group, growing those aspects, and kind of just added responsibilities as we grow. And I guess the rest is history. So that's how I got here today.
So I gave a little bit of a background on First Solar, but could you give us a little bit more in depth about what you guys do and your mission and kind of a high level overview of your technology? Sure.
So we use, we're a little bit different than most of the conventional solar that you see out there today. We do not use silicon. We use thin film. So we use CAD-TEL, cadmium tellurium compound. Basically, we vaporize that compound, place it onto a sheet of glass as one homogeneous platform. Then we isolate cells through laser scribes, seal it together with another piece of glass, and create a really nice photovoltaic. The cadmium tellurium that we use are really interesting products, and Marley, you hit on it early on in the introduction. they're byproducts of copper and gold mining, right? They sit in slimes and sludge off to the side, and we're actually able to take those, work with smelters and refiners to separate the tellurium and the cadmium, compound those together, and then take those and transform them into the module. You talk about the entire life cycle of it, and appreciate the words that you said at the very beginning. We actually do have a closed loop process. So we're actually able to recycle greater than 90% of the value of our modules. Our glass can be recycled. It's actually used in bottles across the US and Europe. The cadmium and tellurium are actually refined and reused in products. Inner layers, copper wire, and things like that are utilized as well. We have 3 main manufacturing facilities in Northwest Ohio. We have one in Northwest Ohio, one in Vietnam outside of Ho Chi Minh City, and one in Malaysia outside of the city of Penang. Together, those 3 sites manufacture just a little under 8 gigawatts of energy a year that we can produce annually. And that's about a panel about every 2.7 seconds, around the globe, we're producing when you put things in perspective. And so we're pretty excited about that.
So you obviously have some international business. Are all of the US sales manufactured domestically, or do you export some from the international locations, or how does that work?
Yeah, great question. So we do, majority of our U.S. manufactured product stays in the U.S. We do import some projects, with Malaysia and Vietnam product. There's a lot of demand here in the U.S. and we, we want to make sure we serve as much of that as possible. But all of the U.S. stuff, pretty much stays in here, unless there's like a specific, for example, the U.S. government has programs with the Export-Import Bank of America that we work with, when they need to send U.S. product overseas, to help with developing countries and things like that. We do participate in those programs with them. Other than that, the U.S. product stays, and whatever we can't fill with U.S. Supply, we bring in from Malaysia and Vietnam. But that kind of leads into, one of the things that we're doing right now is we're expanding right in the U.S. We're adding another 3.3 gigawatts in Northwest Ohio right now to help facilitate even more domestic manufacturing that will stay in the U.S.
So a topic that's obviously fresh on everyone's minds right now is the pandemic, and a lot of businesses have been impacted by that. So could you talk about what kind of changes First Solar had to make during the pandemic and how you guys adjusted to it and how you'll move forward?
Yeah, I think when you think about that, I break it into a few different buckets. The first is the overall safety of our associates, right? That was first and foremost. We were classified at all 3 of our manufacturing locations as a critical industry, as we were in the midst of providing infrastructure for many government programs, either in the US or overseas. So we had to run. We had to find ways to run. And like many other people, that ran during that period of time, we used we went mask, we went distancing, we worked on many of the office associates from home, kept only the core associates, at the factories moving on. We converted our laboratories to create our own hand sanitizer internally, so we didn't have to, go outside and worry about those types of things. So that was one aspect of it. Then there was another aspect where you had to start focusing on the government regulations. Being, part of a global network of manufacturing sites, each country kind of had their own, protocols that we had to follow. The US had theirs. In Malaysia, we had to work with the government because they really clamped down in the Asia Pacific area. So Malaysia, you couldn't cross city boundaries. We had to work with the government. Our associates had to have, signed documents to go from one city to another as they came and went to the factories. Vietnam was even more aggressive, where we actually had to quarantine about 900 associates at our factory for over 100 days. So they couldn't leave the factory. We brought in housing elements for them. They actually had movies, showers. They actually had more freedom on our site than they would have outside in the Ho Chi Minh area. So those are two aspects of it. And then the supply chain, right? You look at what it's done across the globe, with the anything that shipped across the ocean, the indexing on materials, and that caused us to think a lot differently about how we think about expansion in the future and our supply chain as a whole, beginning to end. Really made us think differently.
So of all the places, how does the largest US manufacturer of solar panels end up in Ohio? And is there what are the benefits of having this manufacturing in Ohio as opposed to other places around the US?
A lot of people don't realize this, but the Toledo area where we're located actually has really deep ties into the glass industry. Some of the largest glass producers actually came out of this area, very early on. Our technology kind of grew out of that glass industry. A gentleman by the name of Harold McMaster, who helped create furnaces for the float glass floats across the globe, actually had this vision of being able to take a float line and transform it into solar panels, right, as it came off the float. We didn't get quite there, yet with our technology, but we can take that raw piece of glass off a float and transform it relatively quickly into a panel. So that's the first piece of it that allowed us to be there. And then once you start growing, locally, you start building a nice little ecosystem, right? So, as we grew our manufacturing headquarters and on our R&D platform here, you start getting a pool of talent, right? And that pool of talent allows us to continue to grow and expand, in the area. So that's helpful on the people side, and the ecosystem comes with it, right? Your raw materials, as you grow, and that infrastructure continues to grow around you, and you just continue to expand in that way. So that's kind of how we ended up in Ohio, Toledo, and how we continue to grow.
So could you talk a little bit about First Solar's primary focus in terms of sales? Who are your customers, and how are you getting your product out there?
Sure, absolutely. So we are a utility scale energy provider, right? So we do not participate in residential or home rooftops. Most of our projects that we provide modules for are between 40 and 500 megawatts. Those are up to millions of modules. You think about some of our larger ones, in the desert Southwest, those were measured in square miles, right? When you think about how many, how much surface area that takes. Now those lands are, Bureau of Land Management. We work with the ecosystem and things like that to ensure that we're doing things the right way to maintain a sustainable earth as well from those standpoints. That's really our market, utility scale. The US is a big piece of that. About 70% of our market is the US, followed by India, and then the European Union, all in utility scale markets.
So another big topic is kind of energy storage combined with solar or combined with other zero carbon solutions. So could you talk a little bit about our outlook on the energy storage market and how it pairs with solar installation?
Yeah, actually, so storage is obviously going to be one of the key enablers of PV growth in the future. It's also going to be needed for the decarbonization that's been talked about so much over the past, several months and years. The U.S. is going to need to continue to invest, in that next generation of storage technology. And you read more and more every day about what's coming online. That's going to extend the use of solar energy well into, the night after the sun set. The software and control systems have to come with that as well, right? From the grid integration standpoint, they have to accommodate that higher level of solar penetration as we move forward with the storage platforms. You think about it, and I think the Department of Energy, predict that storage will expand from about 24 gigawatts in 2019 to about 1,600 gigawatts are needed, by 2050 to hit the decarbonization goals that everyone wants to meet. The development in storage is obviously going to be, key to that growth of solar to be part of that, right? We need that to continue to grow as part of the renewables, of the electricity system. Years ago, for solar, we used to have a project development business. And actually, while we were in that industry, we were actually one of the pioneers, one of the first at pairing storage with utility scale, several years ago already. So we believe it's absolutely necessary to continue the growth of renewables, particularly the solar energy, into the future. And we fully support, the technology and the investment in those, throughout the globe.
So could you talk a little bit about how the Section 201 tariffs have affected First Solar? That's also been a big topic of interest recently.
Yeah, that's been a really big topic. So, our position has always been that, that we need a level playing field where we can compete, on our own merits, right? To say that we're uncompetitive without tariffs is to say that the competition, China in this case, is playing by the rules of free and fair trade, which isn't true, right? The fact is that we're more than capable of competing against solar panels made in China, which are cheap only because their manufacturers benefit from, really increased state subsidies and subsidized coal electricity. That's actually in violation of WTO rules, as we move forward. We've competed against, the bifacial cells and modules that have come in from Southeast Asia that continue to be, exempt from the anti-dumping and countervailing duties, and will now be exempt from the 201 tariffs. Moving on, that came about just the other day. When we think about a level playing field, we're not looking for a leg up or an advantage, right? A level playing field from our perspective, is one where technologies can compete on their own merits, rather than relying on the subsidies of the government, of the Chinese government, which have really continued to undermine the competition and innovation. That being said, we're not currently a specific party to the efforts to extend 201 tariffs, because we believe that in the long term, a durable industrial policy, such as the manufacturing tax credits and things like that are being talked about under the Build Back Better Act, can be a much better way of reshoring and scaling American solar manufacturing. We do believe that in order to grow a self-sufficient American solar manufacturing industry, while leading the development of those future technologies, the U.S., has to continue to incentivizing high-value domestic manufacturing, and that enables the domestic manufacturers to compete on their own merits and give the U.S. developed, future solar PV technologies a fighting chance against, these competitors from overseas.
So we know that you guys are the largest PV manufacturer in the US. And I think you mentioned that you had about 20 gigawatts worldwide. But could you talk about how big your company is, how many employees, how big the facilities are, and your annual sales?
Sure. So we have just a little south of 6,000 associates globally. Our sales are net sales right around $3 billion a year, is what we've had over the past several years. Our facilities themselves, one of the neat things about our technology is that all of our manufacturing sites are actually copy smart replicas of one another. So whether you sit inside of our Perrysburg 2 factory, or one of our Vietnam factories, or one of our Malaysia factories, they all look the same. They all have the same equipment. They all have the same conveyor systems, right down to the supply chain aspects that we work with. So being able to replicate quickly is really important to us. So having that copy smart type mentality allows us to really push out efficiency programs really, really quickly, which is very important in the competitive market that we're in today. Each of those facilities, they're about, if you look at our newest ones that we're building right now in Perrysburg and India, those each are, about, 500 to 700 people a piece. It's about $700 million of capital investment by themselves. And each of those buildings is about 2 million square foot under roof. So they're fairly large facilities getting to our new product launches.
So is it much cheaper to manufacture in Vietnam or your Malaysia plants, or is it around the same cost, or how's that comparison?
There's many things to look at when you look at it as delivered price, right? There's obviously certain aspects around the globe where different regions have different benefits than others. The US, believe it or not, has really good, energy rates when you compare them to, the Asia Pacific region. Asia Pacific obviously has a potential advantage in labor rates, compared. You look at the shipping of bringing Malaysia product and Vietnam product into the US versus a Perrysburg, Ohio product that's already here, there's an advantage for, for the US manufacturing. So all those certain aspects, of their cost profile may differ. At the end of the day, they get really, really close to one another. The reason why, we look at, why you want to spread a little bit across regions and why we picked the regions that we did is many times is due to supply chain. So we want to be close to glass float plants, right? Because that's one of our biggest bill of material items. That's very heavy and expensive to ship from location to location. So we try and be close to float plants. The other thing is that as we ship those products across the globe, we want to be in good shipping lanes that are easy to get through, across the globe. So we look at those balances as we look at where we want to expand and where we put our factories.
So speaking of expansion, do you have plans for opening more plants worldwide or within the US, or I assume you're growing rapidly as solar is advancing?
We would love to continue to grow. Right now, we have 2 factories that are currently under construction. We have a 3.3 gigawatt factory that is being built about 300 yards from our existing factories in Perrysburg, Ohio. And they're also doing a sister factory of that in Chennai, India, as we speak. Both of those are expected to come on in Ohio will come on in early 2023, and India will come on about 6 months after that. I think as we look at where we put our capacity, we obviously want to balance that. We want to ensure that we're putting capacity where it needs to be. Expanding the US makes absolute sense with the way that the policy and the need for continued renewable energy is growing in the US. India is one of the fastest growing renewable markets in the world. So having a domestic manufacturer for that market makes a whole bunch of sense for us. We're going to double our footprint, with those 2 factories. We'll go from about 8 gigawatts to close to 16 gigawatts with those 2 factories coming online. So we'll probably wait a little bit before we make any more announcements. Those are pretty substantial builds for us, but absolutely we want to continue to grow. There's a lot out there that we can look at and a lot of unfilled demand that we think our product is a really good fit for in the future.
So we're about halfway through, so I think I'm going to transition to some of the questions in the chat. We've got a bunch here. So got a few technical questions about the technology. So you mentioned you have the thin film technology rather than the silicone. So how has that been able to keep up with the increasing silicon panel efficiencies?
So actually, when you think about it, CAD, if you look at the band gap engineering, right, that's done with silicon versus CAD-TEL, we actually the high end efficiency is actually greater in the band gap. So, we've been able to do that. I think one of the differences is how the efficiencies and improvements are developed. Since we're really the only one of mass scale in CadTel around the globe, we have to really do a lot of that development on our own, right? Inside of the silicon industry, you have the equipment providers, you have the raw material suppliers, and you have a consortium of manufacturers that work together to bring those enhancements on. A lot of times it's not the company or the manufacturer of the panels that's driving the efficiency, it's actually the equipment providers, that are driving that R&D aspect from it. We have we spend, I think over the past 7 or 8 years, we've spent over $1 billion in R&D alone in the state of Ohio at our R&D center. We have a very focused program where we work, obviously internally, externally with the government labs and with several, academic institutions to help grow it as well.
So you mentioned that you work primarily with utility scale solar. So could you describe how big each panel is, how this compares in size to the silicon panels? And then do you use fixed mount or like a solar tracking system?
Yeah, so our size, we're about a little over 2.4 meters squared. We're tall, about 6, so 6 foot by 3 foot, round numbers. We have a underneath wrapped frame, so we don't wrap the edges, so we can actually mount fixed tilt or tracker, depending on where it needs to be around the globe. US is a lot of tracker systems. India, as an example, is a lot of fixed tilt systems. A lot of that is driven by balance of system costs and things like that, and how you get the energy payback out of the systems. From a side-by-side comparison, the size is about the same as a crystalline silicon. We're slightly heavier weight-wise. We're a glass-on-glass, so our substrate and our superstrate are both glass, whereas many times in silicon, it's a glass back or a glass front with a different type of backsheet on it, which is a little bit lighter for them. But overall in the field, size-wise, they're pretty much the same. That was a big transition for us in 2018. We used to be at a much smaller form factor, and we ripped out every piece of equipment in our fleet from 2016 to 2018, replaced it to actually move to this larger form factor. The new factories in the US that we're building in Ohio and India will actually be even bigger than that. They'll be, close to, 2.6, 2.7 meters squared, just big enough to really fit inside a, trailers and containers to move them, from the factories to their locations is some of the things that become your constraints, as we move forward. But really you want to get as many watts, per lift, off of a crate onto a mounting system. So that's what we drive for. So you do that by size, efficiency, and those types of elements.
So First Solar puts a lot of emphasis on their life cycle carbon impact. So could you talk about the greenhouse gas embodied in your manufacturing process and transportation, et cetera, the whole life cycle, and how that compares to some of the most fuel efficient fossil fuel power systems?
Yeah, so when you think about it, and I think you had mentioned it early on, we have, the smallest carbon. We make it it's our policy, right? We're a sustainable energy company. We have to do things the right way, right? That's how you create responsible solar, right? And that's a big mantra inside of our company, whether it's how you source material, how you create the solar cells or put it in the field or recycle it, right? Responsible is really the key word that we're focused on. We already are the smallest carbon footprint. We already have the fastest energy payback. And we also have the lowest life cycle water use. We want to continue to push on that. We generate cleaner, solar electricity, obviously by those aspects that than conventionally manufactured silicon panels. This enables our customers, right, whether they're competing with fossil fuels or other renewables, to decouple their business growth from the associated aspects, of conventional electrical, electricity consumption and generation. We continuously work to drive down the environmental footprint of our modules. If you think about it, in 2020, we actually committed to going, 100% renewables for all of our feed energy into our factories by 2026 in the US, 2028 Malaysia, Vietnam, which will enable us to reduce the carbon footprint of our modules by an additional 40%. When you think about, when we assume, the average worldwide irradiance and, the grid electricity emissions, the 30 gigawatts that we've already put in the field, since 2006, 2007 timeframe, we've displaced over 21 million metric tons of CO2 equivalents, per year, over their lifetime. And to put that in perspective for folks, that's about 15 million average homes, 350 million trees, or 54 billion liters of water, over that time period. Every year, we work to displace more than 10 times the amount of greenhouse gas emissions that we emit through our global operations and supply chain. And every year we work to improve that, time and time again. So it's a huge focus. Our customers, our associates, our board of directors and society, right? The fact that people, watch us, do that, of how we manufacture is important to hold us accountable to that. And we take it very, very seriously. If you flip it, a little bit to the chemical intensive and the energy intensive crystalline silicon side that we compete with on our renewable side, it's a huge difference, especially with the, you read about, with our competitors from China, most of their energy today comes from coal, right? And yes, there are aspects of clean coal around the globe. That's not what they're using, in the manufacturing of their facilities over there. And we have to continue to drive that, right? In our side to help differentiate and create the difference between ourselves and our competition from those standpoints. You look, about our mining byproducts that we use, right? That takes a lot less energy to convert, the CadTel from mining operation to photovoltaic is a lot less energy intensive than all of the steps in the polysilicon, supply chain when you look at it end to end as well. So, that's kind of where we're focused.
So we've got a good question here. How do you think the solar energy field will change over the next 50 years? And what are some of the field's greatest challenges?
Well, I think, great question. I think, I think there's a few different places when you look at, if solar were to expand, which it will and grow, I think you have to look at a few things, right? One, they're very similar to any other industry when you're trying to grow it, right? You got to look at your labor, you got to look at your finance, you got to look at your government policy and your supply chain, right? So if you think about, labor, government policy, and supply chain, they're, really linked together, and they actually collectively pose a more significantly challenge than the availability of financing a project, right? So I think those are the areas that we need to look at. I think you have to look at a scenario where where we have to do things, responsibly, right? With the labor, we have to do things responsible with the supply chain. I think those are the foundational aspects of it, where we look at it. I think, the unfortunate reality is that, no matter what industry you're in, there are geopolitical aspects that come into play. I think those have to be rationalized across the globe as well, to create, a platform that allows, free and fair trade on all of those aspects. I think we have to continue to grow the innovation. We have to incentivize innovation. Just like they used to do in automotive on fuel efficiency, we need to do the same thing, in our efficiency of any type of energy, regardless of whether it's solar or other types, moving forward, we have to look at it. So I think those are the aspects that I would look at, from a growth perspective. The supply chain has to grow, right? You look at, just the amount of steel, copper, concrete, the collective raw materials that are being used today in the world, and how much we have to grow those infrastructure to support, grid integration of solar or other conventional, power means is an important aspect. So, those are the pieces that I think really need the focus. And those are all linked together. Like we said, you have to have the labor to help that piece. You have to have the policies to help grow it. And you have to have the supply chain around it, to grow it as well.
So how solar panels work, a photon is going to hit your panel and then electricity comes out. So how efficient is this process? And then how much room is there left to go theoretically?
I'm not gonna state the high end because I'll get it wrong if I our CTO will chastise me if I get it wrong. Right now, we convert upwards of 19% efficiency. So 19% of the photons that hit get converted to electricity. We grow that every day, right, in our factories. It's our core continuous improvement focus day to day, and then obviously our long-term advanced manufacturing projects as well. There's conversion efficiency, and then there's also the energy output that you gain throughout the day. That's important as well, right? The kilowatt hours of generation that you create. And one of the neat things about our technology is that, when you look at the temperature coefficients, when you look at the long-term degradation rates, when you look at, shading protocols, things like that, there are inherent benefits to CAD/TEL that actually, even when you're slightly different on the conversion efficiency, when you add up, over the entire day, it's a benefit, in many locations around the globe where we have a leg up on the competition. So I think, conversion efficiency, one aspect, but you got to look at that whole day, that kilowatt hour aspect that you drive to as well.
So we've got a couple questions about the lifespan of your product and what are the biggest risks while they're out in the field.
So we have a 30-year warranty, right? And that 30-year warranty includes workmanship and power output. Our modules degrade, at a certain percentage, every year, depending on the climate that you're in, and that's a warrantable aspect. It's competitive. We don't see anything that is a drop-off event, right? That just, there's no cliff, right? It's just this steady decline of conversion efficiency over the lifespan of a module, which leads to time, periods of time, and we've done a few of them where we've actually repowered, right? Where it makes sense, with product that we made in 2005 that was, now, we were making, 50 watt, panels, in 2005, 2006 timeframe. Now we're making, 450, 460 watt panels. There's some mathematical sense that says, hey, now's the time to rip and replace and upgrade, type of modules. And it's not necessarily anything's wrong with those modules, but I can create more power, out of that plot of land that I had before and create more benefit, for the power producer or utility owner or things like that. We think of it in those aspects.
We've got a question about what percentage of First Solar's budget is devoted to R&D.
Round numbers, we spend a little over $100 million a year on roughly $3 billion of revenue. And I want to be cautious on that because our that's straight R&D spend. One of the other aspects of R&D spend is actually the way that we manufacture itself. If you think about it, since we have all the factories running, very as close to identical processes as possible, we're actually able to create, almost full factorial DOEs globally. We're able to monitor and understand how different ovens perform at different temperatures, and the combination of all the events, it actually allows us to grow organically as well from a improvement standpoint. And that's not included in that anything that we do in the manufacturing line for continuous improvement. We actually, in our original Perrysburg factory today, we actually utilize a significant amount of that capacity for efficiency development on the line itself, not necessarily in an R&D lab on a coupon or anything like that, actually on the panels. So when you think about all of that aspect, it's a pretty sizable amount of money.
So one problem we know about solar panels is that they just take up a lot of space, especially these huge solar farms. So how does First Solar address this issue? And do you have any plans to potentially capitalize on rooftop space on commercial or residential applications?
Yeah, great question. So I think, there's two pieces to it. One is when you're doing, selection of sites and lands, making sure that you understand what is the value and benefit of the land that you're working on, and ensuring that you don't do anything to upset the ecology or ecosystem in those locations. And we're very focused on that. We have an entire team that, analyzes those types of things when we build sites. How do we ensure, that the animals or the earth or anything like that around it are protected. Sometimes that means your fence can't go all the way to the ground. Sometimes that means that you can't have panels so close together. You have to have nesting locations or whatever across it. So we're very focused on that aspect. I think some of the ways that you help get better at that is you continue to drive the efficiency and energy utilization of the panels, right? We want to continue to drive that so you can get the same amount of energy out of less, square footage, which is something that we definitely want to do. The other aspect, when you think about it, is I lost my train of thought here for a minute where I was going with that, Marley. The other thing that we want to do is, when we look at commercial and industrial versus residential, we have done, C&I space locations. I think that is a route that we have worked in, specifically in some regions such as Japan and things like that, where we've went into those markets to see what value we can bring and make sure that our product is the right fit for that versus the utility scale. Our modules are really not set up for residential. There's just different aspects, from a logistical standpoint of getting modules to and from on top of rooftops, things like that, and very small, kilowatt value aspects. It really doesn't make sense for us. But definitely the C&I space, commercial, industrial, where you're looking at those larger, warehouse type rooftops, does make sense. We have them on our buildings in Ohio and in Germany, right? We run rooftop systems there as we speak. So it is a place to look.
So some people claim that renewable energy technology is ready to meet climate goals, but we just need to deploy in greater quantities and more quickly by focusing on policy, investment, etc. So this may be true for the manufacturing capability. However, maintaining sustainable product life cycles, do you see the industry prepared to meet these goals, and what is holding us back?
I think if you look at it from a whole product life cycle standpoint, you start with the, we mentioned it early on, as the responsible supply chain aspect of it, right? How do we create, where do we get our silicon from? What are the aspects? How do we grow that? How do we, drive that supply chain to make sure that it's meeting all of the ethical standards, along with the cost effectiveness moving forward? I think there's a lot of focus that needs to be done there from a responsible business aspect. On the back side of it, we'll skip the manufacturing piece for a minute. On the back side, you talk about the recycling aspect, that we really don't have there are no solid real solutions yet, for a silicon recycling program at a large scale that we've seen. We know that our technology is capable of doing that. And I think in order to enable that, you have to have that closed loop cycle. And I think that's one of the focus areas that we need to continue to drive in, moving forward to create that aspect.
We've got a slightly more technical question. If you're allowed to answer, do you have any prospects for multi-junction thin film?
I think, great question. I think that, obviously when you look at next generation PV, I think, whether it's multi-junction or bifacial, tandem, whatever the technology is going to be, I think that obviously has to, be a thought process. Where we're at on it, I think it's definitely a technology that is looked at on an ongoing basis, for everyone, in the industry. I think we have a leg up on most of the competitions, because for most multi-junctions, you need some type of thin film technology to go with it, whether it's in an amorphous or a SIGS or a CAD-TEL, to marry with the conventional silicon. Or if you're looking, further into the, organics or the perovskites or things like that moving forward, a lot of those are thin film type of deposition aspect that, where I think we're positioned well if those technologies were to take off and prove themselves out. You got to balance those types of things, not with just the energy, but is the, cost effectively, how do you get there as well, right? Because you're marrying the two most expensive parts of a solar panel together, right? Is that cell development. You're taking those two pieces together. If you're not getting enough energy, benefit out of that, what's the value that you're creating? So, I think that's going to be one of the things that has to be continued to investigate there, is to doing that, in a competitive manufacturing environment where you have the supply chains and everything that can come together to do it effectively.
All right, we've got 7 minutes left, so I'm going to try to hit a few more here. So could you talk a little bit about the state of advanced electricity storage technology, and with current technology, what % of electricity demand can be provided by solar and wind?
Wow, I don't know if I know that answer off the top of my head. I'm not the marketing guy. I haven't read my Woods Mackenzie outlook the past couple days. Can you repeat the question one more time? I'll see if I can take a stab at it, Marley.
Yes. What is the state of advanced electricity storage technology, and with current technology, what % of electricity demand can be provided by solar and wind without damaging the post-industrial US economy?
I'll be honest, I'm not even going to take a stab at that one. I don't have enough detail in front of me to answer that off the top of my head effectively.
No worries. What is growing faster, the demand for electricity from electric vehicles or the supply from the solar industry?
Yeah, that's a great question. I think, one of the things that we are watching really closely is the electrification of the vehicle market, moving forward. The purpose of, as that vehicle electrification grows, the purpose isn't to refuel those cars with, fossil fuel, technologies. I think it's going to be a growth aspect. We look at it as one of the drivers out, beyond 2030 to start looking at what, GM and Volkswagen and some of the other industry players in automotive are committing to. I think one of the things there that we have to look at is the infrastructure of how that gets done effectively, whether those charging stations are standalone, are they fed, from a renewable source directly connected to it, small scale solar, community type solar programs, or are they fed, off of a grid, that's supported by solar. I think that's some of the things that we're watching really, really close of how that happens. But that's definitely going to be a driver in the future, specifically in the European Union and in the US. We're watching that very, very closely. I think that the manufacturing capacity right now outpaces that growth. I think it'll take time to convert, that infrastructure to accept, all of the renewables, on the vehicle side for a bit.
This might be a quick one. What is the cost of 1 kilowatt hour of first solar electricity compared to a state-of-the-art combined cycle gas turbine generating plant?
I don't know off the top of my head what a combined cycle gas turbine factory would be. I can tell you that when you look at levelized cost of energy, from the life cycle where it includes, the maintenance and aspects of that, we are competitive with them. When you think about, I think the way that you got to think about it differently is not just the cost of my panel, but it's the entire balance of system, that goes along with that, right? The inverters, whether or not you have storage with it and things like that. But it's competitive, in the US, today across the world or across the globe, we're pretty good. You look at what, and I think it was Dubai, back years ago that broke that 5 cent a watt, 5 cent, kilowatt hour barrier. And it's continued to drop. You look around the globe today, and there's places where solar is coming in, 3.5 cents per kilowatt hour. And a lot of that depends on obviously the region you're in, what kind of mounting systems you're using, and that type of thing as well. But it's competitive.
So we've only got a couple minutes left. So to close out, do you have any just kind of some advice or closing thoughts for either current case students or alumni who are, obviously, if they're here, they're passionate about energy and the solar industry. So just if you have any closing thoughts.
So I'll start with, for the students, and the case course load, was really, really challenging for me. I will admit I struggled many times, through the process. But it really forced me to prioritize, focus, plan, and collaborate a lot with others. And all of those directly correlate and are relatable to, how you proceed once you leave the university. So I think that was an important lesson learned for me looking back on it. I think the logical thought processes that you learn at at CASE, obviously it's a great help in solving problems. I'm a firm believer in this, and the overall standard of education and learning that you get at CASE, don't take it lightly. It is a differentiator in helping, in the quickness and applying knowledge and pulling something from the past that really stuck. You do not underestimate that. For those who are, those that are beyond, graduation, I think, whether it's solar, whether it's wind, whether it's clean, other clean energies, I think there's an opportunity for all. I think what we have to focus on is how do we get better, right? How do we work on controlling the climate change? How do we work on, making it a more sustainable Earth moving forward? And there's so many aspects that we can look at, not just in solar, but across the entire platforms that we all probably have an area of influence and as well. And I challenge all of us to continue to drive to that.
Well, with that, we are just about at time. So I want to thank you so much, Mike, for taking the time to talk with us and answer so many of these questions. And we didn't even get to all of them. There were so many in the chat. So we really just want to thank you, and thank you to the ThinkEnergy students and alumni who helped to set this up, and just thank you again.
No worries. Thank you. Thank you for having me. And I hope it was worthwhile for everyone. Thank you, Marley. I really appreciate the time.